Now here's the next question, a very easier one from the straight line. It says that lines are drawn parallel to this line which are located at the distance 3/5 from the origin. Then which one of the following points lie on any one of these lines? Definitely the lines are more than one. So let us see here the figure first. The figure is here for us, which is again showing you these two are the lines which are at the distance 3/5 from the origin, and these lines are parallel to the given line. Let us see what is the line which is given to us. It is 4x minus 3y plus 2 is equal to 0. So any line which is parallel to this line we can assume as 4x minus 3y plus alpha is equal to 0, because these are the parallel lines. Now we need to find out the alpha. What is given to us is this distance which is equal to 3/5. So by using the formula distance of a point from the origin to this line, we have a very simple formula here. This is equal to 3/5, and when you find out here you will get two values of alpha. Modulus of alpha will be equal to 3, so alpha will be equal to plus minus 3. So the required lines are, one of the line is 4x minus 3y plus 3 equal to 0, and another line is minus 3 equal to 0. So if you check these 4 points in these lines, you will see third is the correct option, which will be satisfying these lines or any of these lines, and the line which is satisfied by this point is 4x minus 3y plus 3 is equal to 0. You can straight away check this point, but here you will get the left hand side equal to 0. So third is the correct option. Let's move to the next problem. Now here's the next question. It is given that 20 pillars of the same height have been erected along the boundary of a circular stadium. If the top of each pillar has been connected by beams with the top of all its non-adjacent pillars, then the total number of beams is. Now let us see this problem with the help of the figure, which will actually give you the proper understanding of everything what is given in the problem. There is a circular stadium right here, and these are the pillars of equal height. Now it is given that these dotted lines are the beams. The pillars are connected with the beams, and it is also given that the non-adjacent pillars are connected here. So that means pillars are not adjacent. These two pillars are not connected. This pillar is connected to the different one. Similarly, this will be connected here, and this will be again connected here. Now if you select any two pillars out of 20, the number of ways will be 20C2. Now these will be the number of beams which will be required to connect all the pillars. But again, since non-adjacent pillars are not connected, and this also include the non-adjacent plus the adjacent pillars as well. So we have to subtract the number of beams connecting the adjacent pillars. So how many number of beams will be there which are connecting the adjacent pillars? That is 20. So we are going to subtract 20 beams from that, and this number is 190, and if you subtract 20 from this, the answer will be 170. So definitely third is the correct option here. Next problem is from the rate measure. It is given that a spherical iron ball of radius 10 centimeter is coated with a layer of ice of uniform thickness that melts at the rate of 50 centimeter cube per minute. When the thickness of the ice is 5 centimeter, then the rate at which the thickness of the ice decreases. So let us understand this question with the figure what is given to us. So this is the figure here. It is given that this is the spherical iron ball which is coated with the ice of the uniform thickness, and this ice is melting. So what we have to calculate, when the thickness of the ice is 5 centimeter, then the rate at which the thickness of the ice decreases. So let us understand this. We have this is 10 centimeter, and let us assume this thickness at any point is R. Now, what is given to us? The volume, the rate of volume, the decrease of volume is 50 centimeter per cube per minute. That means we have to calculate the volume of the ice at a particular time. Then only we can calculate the rate at which the thickness of the ice is decreasing. So, how to calculate the volume? The volume of this part, that is the ice, this ring is actually the ice. So, this is 4 by 3 pi. Now, we are calculating the volume of the outer sphere. So, it is 10 plus R whole cube minus the inner sphere, it is 4 by 3 pi 10 cube. So, this is the volume of the ice, this is the volume of the ring. Now, we know what is dV by dt. So, dV by dt is given to us. Differentiating with respect to time, this is 4 pi 10 plus R square into dr by dt. Now, please understand here the radius or the thickness actually of the ice is variable. So, we are differentiating with respect to time. So, here we have a factor, that is dr by dt. So, this is the value which we want to calculate. This is given, this is 50 centimeter cube per minute, and the thickness is 5. The time at which you have to calculate the rate, at that time the thickness is 5. So, you have this is 50. On the right hand side we have 2 pi 10 plus 5 whole square into dr by dt. So, we can easily get the rate at which the thickness is decreasing. Again, there will be actually a negative sign here because the volume is decreasing. So, dV by dt is negative. So, this too will be a negative because the rate is definitely the radius or the thickness is decreasing. So, this has to be negative, but again we have to calculate the positive value, or the options are positive. So, the answer, the correct answer from here will be the fourth one, that is 1 upon 18 pi.